Hi everybody, I'm Michelle. I lead the Big Data Tools team at Netflix. I work with Kyle and we work on notebooks infrastructure. I'm going to start by sharing some of the things that we do with data and giving you a quick look at the company. So we have, as of Q3 2018, 130 million members worldwide. We are currently in 190 countries, and we support over 4,500 different devices. So last month, we streamed to 450 million unique devices around the world. So there's a reason why I told you those numbers. We have 130 million customers in 190 countries, streaming to 450 million devices. We have a lot of data. We write 1 trillion events every single day to our streaming ingestion pipeline. This data gets parsed and processed and put into a data warehouse that is currently sitting at 100 petabytes. And every single day we run 150,000 data jobs against that data warehouse. So we have a lot of data. What are we doing with that data? Well, we are using that data to give you guys a better product experience. One of the things that we're trying to do is reduce the amount of bandwidth that people have to consume to watch Netflix. This is helpful here, but it's also especially helpful around the world. So we introduced initially downloading, and then recently we launched smart downloads, where it'll automatically remove the old videos and put the new videos out there for you. We also use it to constantly improve the product. So 21 years ago, this is what Netflix looked like. We have constantly been improving and iterating on the product ever since. Oops. And you can't tell, but those don't happen all in one fell swoop. We are constantly testing additional iterations and additional features to the website every single day. We are evaluating the performance of those, and we are rolling them out based upon the actual experience that customers are having. We are on track to spend $8 billion on content this year, and we use our data to find the best possible content we can for people around the world. So we do this by looking at the estimated audience we have for a particular title, and we use that to make bids on it. So if this is going to be new content, or if it's content that's licensed, we can look and say, well, this is content that serves the entire, or like a large percentage of our member base. So we can spend a lot of money on that content, which is how we get deals like the ones with Marvel. We can also, using that same model, serve smaller niche customers or customers in other countries by backing into the content based upon the efficiency of it. So we can spend less money on that content because it's going to serve less people, but we still purchase that content. So again, we use the data trying to pick the right titles that are going to best serve you. And we are increasingly moving into studio engineering and seeing how we can innovate there. And so we're using the data that we have because we're uniquely positioned to look at how people are viewing data or viewing the titles on the service. And because we are also creating a lot of these titles, we can try to innovate in this space and create a better viewing experience. This is also where you see things like the branching narratives, if you have heard about that, where it's actually an interactive choose-your-own-adventure through the title. So we have that for kids, and we're doing more stuff with adult content coming. And our plan right now is to spend 85% of that budget on original content. So you're going to see a lot more of this stuff. So that's what we're doing with data. That's what we're doing with, well, it's some of what we're doing with data. So how are we doing it though, right? Well, we have people all across the company that are looking at the data. We have people that are looking at it for personalization and search. We have about 60 seconds to capture your attention whenever you come to the site and find a title that we think you're interested in. We're also using it to personalize the images that we show you. Content in Studio, we're trying to improve that entire process to make it more efficient, to make it easier to get the content out faster. We are improving the business, trying to make sure that we are being responsible and that we are being efficient with our cloud computing resources, and growing the company, and also just constantly improving that streaming experience. So we want to test what is that optimal level at which we can deliver content to where we've reduced the amount of bandwidth that you have to consume without compromising the experience you have. So we have all these compression algorithms that we're constantly testing and iterating on. So all of those people that are working in all of those different areas are using the Netflix data platform. What happens is when you use the service, we are tracking your activity. So as soon as you log in, we're tracking the authentication, we're tracking what is the content that we're showing you, because every single member and every single profile is completely 100% personalized for that person. So we need to know, what did we show you to be able to evaluate, was it the right thing to do? When you click play, when you click pause, when you go to the next title, all of those are events that are firing. That's where we get to that 1 trillion events a day. So those trillion events get written into Keystone, which is a stream and ingestion pipeline that is backed by Kafka. It gets written into S3. This entire platform, actually everything at Netflix, all of our infrastructure is entirely 100% cloud-based, based in AWS. So our data warehouse is basically on S3, and we have a logical data warehouse. So it follows the traditional 3-tiered approach where we have a raw ingestion layer, the data gets dumped, we do some processing of that data, we land it into the data warehouse, which is where we get that 100 petabytes, and then we have aggregates that we build upon that, and those aggregates are used to serve reports and data science. The actual process of going from raw to the data warehouse, or going from the data warehouse to those aggregates, we use a variety of different tools, but increasingly Spark is the tool that we're using. So we would use Spark and Presto to do that ETL, or those transformations, and a subset of that data gets loaded out to fast access storage. So this is primarily for us Druid, increasingly Snowflake, Redshift primarily, increasingly Snowflake, and we also have Elasticsearch and Druid. Those fast access storage is used to serve a variety of data viz options. Tableau is used heavily across the entire company. We also support D3, of course Jupyter, Abacus, and some other internal custom viz. And we support a variety of tools for interactive use, or interactive exploration of the data in the data platform. So we have a tool, or really basically a landing page that's called the Big Data Portal, from which all of the tools in the platform are accessible, especially notebooks. We also can run Presto queries or Spark jobs directly from there. We have a variety of different ways that people can access this. This entire platform is accessible to every single person in the company who wants to have access to it. So we believe that in order for us to do really great things with data, we need to make sure that people can get to the data that they need. Obviously, PII data is excluded from that, but all of the non-sensitive data is completely available for people to work with. So within, again, kind of going back to those different areas or departments we had in the company, we have different people working with the data doing different functions. We have data viz engineers who are primarily focused on building Tableau and other custom viz. We have analytics engineers who are working on basically the full stack, so they might be doing aggregates or denormalization, as well as data viz. We have data engineers, and data engineers for us is basically a software engineer who can work with that data, who's specifically focused on data, and they understand distributed processing very well, and they take care of that trillion row data set to make it consumable for everybody else. Algorithm engineers who are constantly iterating on our personalization and compression algorithms and other algorithms. They build what's called, or what I'm calling data products, right? So the deliverable for them is data. We also have a whole bunch of people that are focused on delivering insight from that data. So their deliverable is an insight, and that could be a research scientist, quantitative analyst, data scientist, machine learning scientist. This is imperfect. I realize that people can fall into different categories, but generally speaking, this is how we divide them. And then those insights are surfaced to other parts of the company for making business decisions and product improvements. So every single person in the company has access to the data. And when we go back to this and we look at the people in the data insights and the data product layer, the goal we have, and we're not there yet, but the goal we have is that any of those people should be able to go to our tools and answer a question like, how many people viewed a specific title the previous day? We want to make that as easy as possible for people to get to those types of answers. And so everything is readily accessible for everybody to do whatever it is that they want to do. All right, turn it over to Kyle.
See, does this one work pretty well? Okay. Push. There we go. Okay. Right, so notebooks and Netflix. The way that we do the infrastructure, right, to enable all these people so they get access to it, I mean, the base layer of all of it is a Docker container that has all the dependencies that someone will need, including all of our glue layer, like Python libraries to access the data platform itself, to issue jobs, to make SQL queries, Presto queries, give them access to magics to directly call %% SQL, and then whatever query they want to make. And as much as possible, those tools need to be readily available. Right? When they make that query, they get back a data frame, and then they should be able to visualize that data frame as fast as possible. So this is all about enabling these users. And so like when they run a Spark job, for instance, like it's going to run, their driver is running on their container, and then it's interacting with Genie, which is our, it's escaping me right now, but it's basically the way that we'll run kind of data jobs. That's the easy way to put it. So it'll get access to what version of Spark we're going to run and connect you to a cluster so that you can actually run the rest of your Spark job. And it's reading and writing to S3, like Michelle was saying before. And then when you're writing your notebook, currently we're writing it out directly to EFS, which is a network file system from Amazon. So this is all great, except for as a data scientist, if you're productionalizing it, or you're kind of anybody within that category, you end up having to pull your code out of a notebook and then either have a data engineer help you with doing ETL, or you're figuring out exactly how you're going to get a job scheduled and how you're going to get that exact notebook out run as part of an ETL pipeline or maybe a model that you're building. And so it's just like, ugh.
I'm going to pause you right there. Hey guys, we've got seats up here if you guys want to sit down.
Or 1, 2, 3 seats.
But no, 2, 4, 6, 8.
Okay.
Yeah, we got seats.
So one thing that we've enabled and we're pushing further on is that we make it easy to schedule a notebook as a job. So we have a scheduler that's called Meson, and on Meson you write a template of what you're going to run, and the notebook that you're going to run along with it. And that notebook we actually allow it to be parameterized. You can set a few cells, A equals 3, A equals B equals 2, or whatever, and then change those by changing the YAML file for your workflow, basically, so you can iterate across a bunch of different parameters. And then that comes to Papermill, and Papermill itself actually just runs the notebook. It's just a notebook runner that knows how to handle parameterization. You don't have to run them as parameterized notebooks. Some people use them to basically just generate reports. So now they have this end-to-end workflow where somebody can do ETL, and then when they look at their job the next day, effectively have a report, right? They can get the table output from pandas, they can do their own plots, and they can evaluate how that job actually performed, which is important because if and when a job fails, you can look back at this artifact, which is this output notebook, and know the reasons why it failed. Because in the past, if people were running a script through this whole engine here, you basically just have this pile of standard error and standard out to look at, and you're like, okay, which thing broke and why? And then the notebook gives you this nice artifact that contains it all together. Yeah, so everything's awesome. I guess I just talked through this, but I can talk. So this will go through. So for Papermill itself, I mean, when we get the source notebook for everything that it's gonna it's gonna pull from databases, it's gonna pull from files or other services. We can set parameters directly in the notebook. You denote that a particular cell is a parameter cell, and then run it. And Papermill itself is just working with the Jupyter messages directly to build a notebook in memory. And it's actually using NB-convert under the hood. And while we're doing that, we're also streaming the input and output that happens during the course of running that. So while the notebook is being written, we can still see a live view of what's happening with that job. Just in case for some reason we weren't able to write the notebook, we've still got something else. And this is all for like long-term reliability. We know that not everything's gonna work out, so we always have to make sure to stream these same outputs and logs to another place. And then when we write the output notebook out, like, it's not just writing out the notebook, right? You've probably written something that's writing out to Hive, and so you can think of the artifact as being your presentation layer over the real job that you ran. But the real effect is that you wrote to a table in Hive. You maybe stored some objects in S3 because you had a model that you built, and you serialized it and you put it up on S3 for later use. Right. So like in nteract, the way that we do this is that we just have one quick thing to toggle a cell as a parameter cell. And then Papermill knows how to pick that up. And then you can see it visually when you get to it. And then an important part of this so you've got this output notebook, you've written it out, people are working with it, you actually want to be able to share it. So we have another service that looks on top of all the notebooks on S3, as well as all the notebooks on EFS. That's called Commuter, and it's just a viewer that uses the same React components from the Interact front end. And then we just keep building on that to build this ideal interface for reporting. Within a recent internal report, people were actually passing links to Commuter, whereas normally they'd have offloaded stuff to Google Docs and made their memo. Their memo instead was just a link to their notebook on the inside. And they hid the code, they hid the source code for the cells because they can toggle that easily too. And then someone was able to just look at it like it was a document, because that's what it is. Right? So what's next?
Oh.
Is that you? Nerves.
Yeah. Okay. So we've done a lot of work on notebooks, but we're not done. In fact, I would say we're really just getting started. One of the things that we want to improve is the entire Scala experience for our Scala developers inside of a notebook. They are using notebooks for a whole bunch of different things. One example is the image personalization. And so we are constantly testing variations of images to see what is the right image to show. We do this across the entire population currently. And so what we saw was around, I want to say it was like a 23% lift in click-throughs based upon the image. We are now working on personalizing that for every single person. So when you look at something like Stranger Things, it's an interesting case because it hits a lot of different genres. It's hitting the 80s nostalgia. It's hitting horror and sci-fi and mystery. And when we are showing you this image, what we need to do is express to you why we think this is interesting to you. We want to express what's appealing about it for you. And so we need to show you an image that really denotes that. And so the algorithm engineering team is focused on this type of problem, but because of the scale we have, everything they do is pretty much in Scala. So we want to improve the Scala experience for them. A lot of them, I would say it's mixed 50-50 maybe. Half are doing Jupyter notebooks, half are doing Zeppelin. And so our goal right now is to reach a workflow parity with Zeppelin and other top offerings. So that's one goal. How we're going to do that is working on improving the Scala kernel to make sure that it's more stable and gives them a better experience. We want to support native data viz, which is where we got to Data Explorer. And again, that's an area that we have something out there, but we're going to constantly improve. And then we want to have better Spark integrations. So you have a pretty good Spark experience right now with Python. We want to give that same experience to all of our developers who are working with the JVM. We want to have better integration. And so integration with the data platform for our purposes. We want to provide a single cohesive platform experience, regardless of who you are and what you're doing. So that means native scheduling. Scheduling becomes just a button that you don't have to worry about going to find a YAML or a job. You specify a schedule. So we want to make that really easy for people that want to specify recurring workloads. We want to surface all of the information that surrounds the actual notebook. So we need to give our users better context. We want to give them visibility into logs and error messages right there in-app. And what was the last one going to be? It just says native.
Oh, oops. It's going to be native. Really
it's going to be native, whatever it is. We also want to improve the reliability of the entire experience, right? So increasingly, people are using notebooks not for ad hoc exploration, or not only for ad hoc exploration and data discovery, but they are using it for mission-critical production workloads. And so we need to give them an ecosystem that supports that type of work. So again, we need to improve and invest in the Scala kernels and other kernels as well. We want to give visibility into the state of those kernels. And we want to have automated source control for our users. That way, they don't have to worry about whether people are editing, they can always roll back. It also enables a lot more around collaboration and being able to discover notebooks. So, going back to this slide, and we looked at all of our users. Traditionally, we've seen notebooks used by our data scientists. And so that would be data scientists, machine learning scientists and engineers, algorithm engineers. That is the traditional notebooks user. With the work that we have done around scheduling, every single job at Netflix will be executed through a notebook, not just the notebooks themselves. So if you're running a Spark job, if you're running a jar, if you've got a SQL job, you're going to schedule that job in the same way that you typically would. You're just going to specify the code. But behind the scenes, all of that is being executed through a notebook. And we have 10,000 jobs. Right now, that's 150,000 jobs a day are going to be executed through a notebook. So we're going to see increasingly that our data viz engineers, our analytics engineers, our data engineers, they're going to be living in notebooks. It gives them a much better experience for being able to test, do data discovery, but also to be able to debug their production workflows. We are also going to increasingly work on in improving the access for the people in this top level, right? So this is kind of directionally where we want to go. We have data engineers and data viz engineers and analytics engineers using notebooks today. We don't really have business analysts or TPMs or PMs that are using it. But as we continue to invest in this, as we continue to make the experience easier and easier for people, as we do more things with notebooks, the goal here is that those people can feel comfortable using notebooks as well. This entire group should be able to be served by a single notebook experience across the entire workflow. So how are we going to do that? Well, one is we really need to lean into simplicity. We're not trying to create an IDE here. We want to focus on making data easy for the people who work with data heavily, but are not necessarily focused on the technical side, like our data scientists. Also making it easier for people who work with data heavily, but who they just want to do things on an ad hoc basis. They don't want to invest a lot of time in coding up data viz, right? So our data engineers, we want to make it easy for our non-technical people to be able to go visualize data, interact with it, schedule it. And a lot of the work that we've done around scheduling has also enabled templates. So templating could be, we can use it for being able to document what the data model is. We can use it to demonstrate how you use a tool. Data scientists can actually launch a template and run multiple templates or notebooks in parallel with different parameter sets. And then Papermill will aggregate across all of those notebooks, right? So we're just trying to make these things that are really complicated in nature really easy for users to do. We also want to lean into integration across the entire platform. They don't really need to know what Genie is or why we care about federated job execution. They don't need to know about S3. We just want to create a very, I would say like a very user-friendly experience. And then we want to lean into collaboration. So focusing on that end goal of a single notebook transcending all of those different user roles, right? It's going to be a very collaborative experience. There's a lot of work we have to do, but that's something that we are keeping at the forefront of our mind.
All the tools that we're working on and we're building in, or as much as possible, we need to lean into open source, whether that's influencing specs for pandas. I just realized we didn't actually show the Data Explorer. Or did we? And I spaced out. No, we didn't.
No,
That's okay.
that was my bad.
I could demo it later. Come to the Netflix booth. I'll show it there. So pandas adopted a spec for us, and us in this case actually means part of Interact. We're like, oh, hey, we really want to drive forward making a JSON format that can end up in the front end that any of the Jupyter front ends could work with to display a rich way of looking at the table, whether that means a virtual table you could scroll through or even a table along with some visualization. And just the same, like pushing on protocols and formats within Jupyter, we want all of that to expand. And we also realize that not everything's going to be a best fit. And that's why there's so many tools even out now today. We're going to keep exploring these spaces and trying to push in areas where, I think in the past people are always like, why isn't Git good with the notebooks? Why isn't this good with the notebooks? And some of it's just about the fact that, there's people have to maintain a lot of protocols and formats and code over the years. And we need to try new areas so that we can, find out what that kind of idealized landscape will be. Same thing goes for Spark. And I'll put this as a message out to you. If you ever wonder why PySpark doesn't have exactly what you need, why doesn't it present more information? Most of what needs to be pushed into it are the reppers. So when you look at pandas, it has its own repr HTML. That's how it gets table onto the page. If you want Spark to output more information for you, you get that in. If you've used PySpark recently, you've probably seen that it now has Spark UI links. Those came from me and Ryan Blue and Holden putting that together to make it so that we could have that in there. As much as possible, we want to keep pushing back within these. There's Netflix open source projects, but then there's all the community open source projects. So I encourage everyone to come and join and work on these. We can partner together, we can build together. Which is a good time, I guess, for me to tell everyone that the community sprints are on Saturday, and you should definitely come because we'll build on things there together. So that's it. Thank you.
All right.
That's
perfect.
We could have played the video, but we did perfect.
So we rushed through that. We know that was a lot of content, and we could have taken it in a lot of different directions, but we wanted to leave adequate time for questions, and we can delve into anything. If we don't have time to answer your question here, please come to the booth. I'm here for you guys, right? So if you have questions, we're happy to talk about anything that we're working on here. And yeah.
I just wondered, can you speak to how we handle DAGs in your pipelines, and especially if maybe you don't really need that if some parameters of one notebook are based on the parameters or outputs of the other notebook, and maybe if you need or don't need your users or analysts to understand the whole DAG, how it worked out.
The notebook is a presentation layer. So when you run this notebook and you get outputs to it, we don't allow it to be used like a function so that doesn't happen. Because there's not a good layer where you can use the output. If the output is you stage data, you write it out. The output is literally you write out to S3 or you're writing to a table, that's okay. And I don't know much actually about how the workflow, I haven't worked with a more complicated workflow, but if a stage ends, because you can chain together a whole bunch of things, if one thing fails that's in a sequence of those, then we don't continue on with the workflow.
Yeah, so basically a notebook should be an atomic unit. Anything that you could think of would be committed as part of a transaction can be encapsulated within a notebook. A notebook can be a complete end-to-end workflow. You can ingest data, transform it, and store it. But as you can imagine, a lot of the stuff that we work with are pretty complex. And so while you can do things end-to-end, You probably want to do that in your simpler cases. If you're trying to do an aggregate or a denormalization, that would make sense to put that entire workflow inside of a single notebook. If you are doing something more complicated, or even if you're doing the aggregation or denormalizing, but it's a very large, complicated data set, then you probably want to break each one of those steps into its own notebook, right? And then we would orchestrate across all of those notebooks inside of Meson. So you'd have to specify a workflow at that point instead of a single. Basically a notebook can be its own workflow. And when we schedule inside of a notebook, we're just scheduling just a single notebook. If you want to do something more complex as a workflow, you'd have to go into our scheduler.
Good.
Just to follow up on this question, actually. Thank you. So just to follow up on this question, in your slides, I saw EFS called out as the output for notebooks, and I think that confused me a little bit too.
So EFS is only used for the interactive compute. So when someone's working in their workspace, when they schedule something as a job, the EFS is not mounted. On purpose, like if they need to pull data from somewhere, they need to stage it locally. Like their notebook should run as if it doesn't know how the file system is laid out. Yeah.
Actually, as part of the scheduling process, we then copy that notebook over to S3.
Yeah, it becomes like one immutable notebook. So like if you've scheduled one, you've scheduled that version. That way you can keep editing your notebook and then schedule it again later. Yeah. In the back.
Hello.
Hey.
For choosing like the different interfaces or images representing shows that you display to the users, how do you gauge or quantify user experience using notebooks or data?
I'm sorry, it was a little muffled. What was the last bit?
Oh, like how do you gauge or quantify user experience using the notebook or data?
Oh, okay. How would we quantify the user experience? Well, we do that through a handful of different ways. I would say one is more subjective. We survey our users to find out what is the overall experience like. We're constantly working with them and talking to them. We're actually in the same org, in the data engineering and infrastructure orgs with our data engineers, and so we have a very close relationship there. The other way is a little bit more discrete, which is looking at the number of notebooks users we have, the number of people who are using notebooks to schedule jobs, how many people are still using Zeppelin because we're not supporting or we're not reliable enough in Jupyter, right? So we would be looking at that type and measuring in that way.
This might be kind of a very specific question, but you mentioned that you have a way to toggle cells in Jupyter Notebooks to indicate that they're metadata, that they're parameters basically. Does that mean you've like broken the interoperability with other Jupyter Notebooks?
So actually before we showed it in here, this actually appears as a tag. And you can do this in the classic, you can use Papermill and with the classic notebook UI and with the Jupyter Lab UI, in the classic notebook UI, you first have to open the tags menu. And so that'll show tags on every cell. And then the tags, you type parameters. So this made it a one-click to add the tag in, but it's compliant with the spec itself.
So you can manually make that tag yourself,
Yep.
You're saying? Interesting, okay.
There's no magic here.
Cool.
We can load the same Jupyter notebook in Jupyter Classic, Jupyter Labs, and Interact, right? So it's still the same notebook, it's just a different way to render the UI.
So with something like normalization, is something that a lot of different
Hold on, wait for the mic.
Oh, sorry about that. So something like normalization, that's probably something that a lot of different notebooks users are doing at the same time, and they might be using different, normalizing in different ways. How do you think about leverageability and letting people share best practices when they're in this environment where a lot of different people are using notebooks?
Good question. We're tackling that in two different ways. One is we want to improve notebook discovery and sharing. So we can share it right now, but that sharing happens with me sending you a link to my notebook in Commuter. What we want to do is surface it in our portal in the same way that we surface all of our other tables. It just becomes another object in our catalog. So people can search for it. They have the annotations around the notebook, and we can say, here is a notebook that does this work. The second way is a separate process altogether that we are looking for trying to improve the overall metrics definition and standardizing across teams. And that's happening in a different group. It's called the Metrics Factory. And so that's something that we haven't really talked about publicly at this point, but we'll talk about in the future.
Okay, thank you.
Yes.
You mentioned you want anyone at Netflix to be able to request any data that they want to look at using the same portal. What kind of fail-safes or caps do you put in the system to make sure hungry data scientists or analysts isn't requesting too much and can bring down some things? Are there notifications or there fail-safes in the systems that keep that from happening? Or how do I know I'm requesting too much data?
Your job will fail. Yes. So you can always ask for, so there are caps on things like memory and stuff, and there are definitely, we give people enough freedom and flexibility, and actually I should put this as freedom or responsibility for how they're going to run the jobs. And if they need more memory, they can get more memory. If they're maxed out on Spark jobs, for instance, they'll know, and they'll find out in H2 query and Hadoop that they're already at their allocation, and they can ask the team to get more resources if they need it. So yeah, there are definitely fail safes, but we give a lot of access out. So
we also have workload isolation. So Genie is a federated job execution engine, and when you define a Genie job, you can specify, is this an ad hoc workload or is this production workload? And so while you can take down the ad hoc cluster and disrupt a lot of people and they'll be unhappy, it's not going to affect production.
I think gentleman in the front.
My question was basically around things like A/B testing and so forth, so the actual machine learning components. Whenever I have an A/B test, and I actually want to evaluate the efficacy of a certain campaign or a certain process. How in this structure do you actually allow for somebody to create a test and then evaluate between the results of two different jobs, test A, test B? How do you go back and evaluate the metrics? Is that something that's built into the system, or is that external?
I would say, how do we enable A/B testing and to be able to work across different tests, right, and be able to surface the results across all of those? I would say two things. Again, we have two different solutions. Our part in this would probably be Papermill. And so Papermill allows us to create a template, and so you could have a template that encapsulates the entire experiment. And when you run it, you could run it with different, different variables or different inputs, or it could be different algorithms, whatever it is. But something's going to change inside of that, and it will allow you to surface those across all of the notebooks. So that's one thing that a scientist could do if they were doing it on an ad hoc basis. The other thing is we've actually built an entire experimentation platform which enables A/B testing. So if you go to the Netflix tech blog, they describe it a lot more there.
Is that leveraging this?
When they run those jobs, it is running through a notebook, but they would use it on an ad hoc or exploratory basis, but it's not. There's a lot more infrastructure that goes into supporting that and trying to make it as easy as possible.
Yeah, so there's an article you can search for about this. It's called All About Testing. It's all A/B about testing, the Netflix experimentation platform. You can read more there.
Have you discovered a non-traditional use for the notebooks while using it? I mean, something that not what everybody else would be using it for. Say, for maybe, discovering a new process or something of that sort.
Go ahead.
I think the most interesting thing that I've seen out of notebooks after seeing it in practice is that less internal tools need to be built, because people can just build something that, they can build this, the notebook is kind of ephemeral in the sense it's just this file. You can make it and throw it away. And the notebook server itself serves as this web server, so you don't have to stand up a whole team just to put up a thing where you're going to analyze some amount of data and be able to change some parameters and toggle between stuff. And so it's phenomenal that people don't have to go figure out how to deploy a specialized server and build up all this tooling when they can just do it in the notebook.
Actually, I think we are at time, so we are going to stick around out here in the hallway, and then we'll head over to the booth. If you guys have any questions, please swing by. Thank you very much.